One of our robots did the Trump dance, which I think was pretty cool. So yeah, our robots can dance, they can walk around, they can interact. I think we're headed to a radically different world.
Oh my God. Instead of walking like Biden, Tesla Bot Optimus Gen 3 now has a full-on Trump-style dance. If you ever thought Optimus was just some gardening robot, a domestic helper, a cook, or a flashy tech toy, forget it. The latest video shared by Tesla and Elon Musk reveals a new leap in human advancement. Right here, Tesla Optimus isn't just walking, it's dancing, hip-swaying, and balancing on one foot completely independently, with zero external support or intervention. Even more surprising, Elon Musk himself and others have confirmed that what we're witnessing isn't some polished computer-generated imagery or AI trick. It's real-time dynamic balance and control. So what exactly has the Tesla Bot Optimus accomplished in the latest update video carefully released by Elon Musk? And what do these new updates mean for the potential sale of Tesla Optimus later this year? Welcome to Tesla Car World.
My prediction actually for humanoid robots is that ultimately there will be tens of billions. I think everyone will want to have their personal robot. You can think of it like as though you had your own personal C-3PO or R2-D2, but even better. Then who wouldn't want to have their own personal C-3PO or...
What major upgrades has Tesla Bot Gen 3 achieved ahead of its official sale? Gone are the days when Optimus merely shuffled across a stage or performed a set of pre-programmed hand gestures. In the latest clip, the robot jumps, balances gracefully on one leg, and shifts its weight with fluid precision, all while its safety tether remains slack. For the first time, a mass-production prototype is demonstrating this level of composure, underscoring Tesla's aggressive push from research to full-scale production. Tesla Optimus showcases a striking display of coordinated movement, executing controlled jumps while shifting its weight seamlessly from one leg to the other. What stands out immediately is the unmistakable sense of rhythm, balance, and composure. The robot doesn't stumble, it doesn't falter. Then comes the defining moment. Optimus lifts one leg and holds the pose effortlessly. It's in that stillness that the truth becomes clear. This isn't a programmed routine or puppet-like automation. What we're witnessing is dynamic, real-time control. This level of precision isn't achieved with basic servos or mechanical repetition. It demands a highly advanced integration of inertial control and continual adjustment of the robot's center of gravity. Each joint responds through refined torque modulation, guided by ultra-high-frequency sensor feedback loops. Most remarkable of all is the robot's ability to maintain or regain balance even when encountering disturbances, something that remains an enormous challenge in humanoid robotics. In contrast, most humanoid robots today still rely heavily on safety harnesses just to stay upright. And even then, their movement often appears rigid, uncertain, or wobbly. Tesla Optimus, however, is beginning to move with the confidence and control that mark a genuine breakthrough. What Optimus demonstrates here isn't just mobility, it's performance. While many viewers have reacted with astonishment, others remain skeptical, asking, is this real or is it AI generated? But when we compare the footage to prior public demonstrations, such as the Wii Robot Showcase in October 2024 and Tesla's most recent internal update shared in April 2025, the clip aligns perfectly with Optimus's known capabilities. Now, Tesla Optimus isn't just walking, it's doing so with theatrical flair. This isn't a dance meant to flex muscles for show. It's a bold expression of how far dynamic control has come. What we're seeing is not just a display, it's a leap forward in robotic movement intelligence. To reinforce that observation, Milan Kovac, a Tesla engineer working on the Optimus project, reshared Musk's post and commented, "More coming shortly. The team has been working very hard in the background, entirely trained in simulation with RL. Many optimizations and fixes have been put in place in our sim-to-real training code and the tether on its back. It's likely there for safety, not for support. In industrial testing, robots are often secured in case they fall. But take a closer look. The line goes slack. That bot is standing and moving entirely under its own power. Kovac also addressed the visible cable attached to the robot, offering a direct response to the skepticism. The cable is there in case of a fall, not actually holding the bot, since this is an early result which will get more stable very quickly. He explained, effectively confirming that the tether is for safety, not support. To further validate its authenticity, Kovac shared some key details about Optimus's second demonstration that followed immediately afterward. According to Tesla's CEO, the humanoid robot's movements in the video are entirely in real time. The performance was fully learned in simulation and transferred zero-shot to reality without any additional training. Here's a little more, and no cables this time. It's all real-time speed, zero CGI, fully learned in simulation, and zero-shot transferred to real. Besides the fact that it's fun, we had to make significant improvements to our robot model in sim, domain randomization, and other techniques which will directly transfer to more practical situations as well, robust walking, and agile full-body control in general. We also learned quite a few things on our hardware and tuned our power profile. I hope it is getting pretty clear that Tesla is much more than an amazing car company. It's the place to be for transformational real-world AI. This isn't the first time Elon Musk has used social media to reveal new capabilities of the Optimus line. Back in December 2024, he shared footage of the robot walking across uneven terrain in a garden. The video was captioned, "Optimus can now walk over highly variable ground, using a neural network to control its electric limbs." Musk ended that post with an open invitation for engineers to join Tesla's AI division, calling it an opportunity to work on exciting real-world AI systems. By 2022, the first functioning prototypes had emerged, demonstrating basic movements such as walking and lifting objects. In 2023, Tesla introduced Optimus Gen 2, which could perform yoga poses, sort objects by color, and execute more coordinated motions, including early attempts at dancing. The latest dancing video, however, marks a significant leap forward in real-time motion planning, showcasing just how far the robot's capabilities have advanced. At the heart of this breakthrough lies Tesla's simulation-first approach. According to Milan Kovac, every movement is refined within the Dojo supercomputing environment, where reinforcement learning teaches the robot how to shift its center of gravity and adjust joint torque using feedback loops accurate to the microsecond. Unlike traditional demos powered by basic servo motors, Optimus relies on 40 custom-designed electric actuators distributed across its limbs and torso to execute real-time inertial corrections while in motion. This sim-to-real pipeline, combined with high-frequency sensor fusion, enables the robot not only to recover from disturbances, but also to perform choreographed sequences with rhythm and grace. Equally compelling is Tesla's transition into limited-scale production. According to Tesla's first quarter 2025 shareholder letter, the Fremont factory has begun manufacturing units for internal use, with over 1,000 robots expected to be assembled this year. The company aims to begin external sales as early as the fourth quarter 2025 or early 2026. Elon Musk envisions a future where Optimus becomes as common as the Model 3, with a price point between $20,000 and $25,000, an affordable range for the mass market that no other humanoid robotics company has dared to promise. To achieve this goal, Tesla is developing assembly lines capable of producing 1,000 robots per month, with plans to scale up to 10,000 and ultimately 100,000 units per month at next-generation manufacturing facilities. This industrial muscle is what transforms Optimus from a research curiosity into a scalable labor platform with world-changing potential. So, how could a Tesla Bot Gen 3, you doubt, become your trusted companion?
Once you have humanoid robots, the actual economic output potential is tremendous. It's really unlimited. potentially we could have an economy 10 times the size of the current global economy where no one wants for anything.
After all, until now, robots that help around the house have been prototypes, laboratory curiosities, or expensive novelty gadgets. But what if I told you that, as of mid-May 2025, Tesla's humanoid robot is poised to become the most reliable household companion you could ever ask for, at a price that won't force you to remortgage your home? First off, let's address the elephant in the room: trust. You're a practical man who remembers when hoverboards were supposed to change the world, only to leave a trail of recalls and burnt-up batteries. You've heard grand promises about mass-market robots before and seen nothing but vaporware. So why should you believe that Optimus will be any different? Tesla's approach is rooted in real hard numbers and a production pipeline already humming at the Fremont factory. In the first quarter of this year, the plant quietly assembled its first 1,000 units. No fanfare, no flashy PR, just straight-up manufacturing. These aren't one-off prototypes. They're the very same machines planned for sale in 2026, each one built using the same assembly line techniques that made the Model 3 a global bestseller. When we talk about price, the skeptics often point out that home care robots have traditionally been wildly expensive. Think six figures? Easy. By contrast, Tesla is aiming for a sticker price between $25,000 and $30,000. Break that down, and you'll see it matches roughly 5 to 6 years of in-home caregiver costs here in the US, which often hover around $50,000 per year. In other words, after you've paid off Optimus in about half a decade, you'll be enjoying round-the-clock assistance at essentially no extra cost. That's an idea that even the savviest retirees can appreciate. A one-time investment for decades of daily support versus an endless stream of monthly invoices. Of course, money matters little if the machine can't do the job. That's where the real magic happens. Each Optimus is equipped with 40 custom electric actuators, giving it the strength to lift 20 kilograms in each arm. Picture your laundry basket piled high with clothes. Optimus can scoop it up, carry it, and help you fold it without breaking a sweat. Climbing stairs can be nerve-wracking when you're alone, but with its advanced balance system, Optimus senses shifts in weight and adjusts its posture in real time, so it can brace you gently as you take each step. This isn't stiff robotic stumbling. This is smooth, human-like movement that adapts to you, not the other way around. Medication management is another area where Optimus shines. Missing a pill can lead to serious health issues, and traditional reminders, sticky notes, alarm clocks, still leave plenty of room for error. Tesla's solution is a built-in scheduler trained on their Dojo supercomputer, which runs millions of simulations to learn the precise timing and context of your prescriptions. Field tests have shown a reduction in missed doses by up to 75% compared to old-school methods. Better yet, each reminder and confirmation is logged securely on the robot itself, so when you visit your doctor, you can simply hand over a digital record instead of fumbling through pill bottles or trying to remember if you took that morning dose. It isn't just big tasks that Optimus handles well. Even chores that seem small, like folding a shirt or carrying a carton of eggs, can become taxing when mobility is limited. In demos, Optimus folded an entire outfit in 30 seconds flat, or carried a fragile dozen eggs across a countertop with zero breakages. Its high-frequency sensor feedback system constantly monitors pressure and position, adjusting grip strength on the fly. That means it can stack dishes, set the table, or even dust furniture without leaving a single fingerprint. All those little jobs that pile up and drain your energy? Optimus quietly takes care of them so you can spend your time reading a good book, catching up with an old friend, or simply enjoying a cup of coffee in peace. I know what you're thinking. What about safety? What if Optimus glitches, loses power halfway through a task, or, heaven forbid, falls on you? Tesla engineers have thought of that too. Optimus carries a dual battery system with 2 hours of backup power, and its motors and joints are outfitted with torque sensors that spot anomalies before they become serious problems. If the robot detects any imbalance or hardware fault, it enters a controlled shutdown. gently lowering whatever it's holding and assuming a support hold stance until a human helper arrives. In the unlikely event of a system crash, the machine is programmed to freeze in place rather than jerk or collapse, so you're never left in a dangerous situation. Let's talk about privacy, because inviting a robot into your home raises obvious questions about data security. Optimus processes 90% of its data on board, right there inside its own secure processors. Video and audio recordings never leave the device unless you explicitly choose to share them. All logs are encrypted with industry-leading 256-bit encryption, and health-critical records live in a separate digital vault that even a security breach elsewhere can't touch. Plus, Tesla plans to open their algorithms to independent audits by ethicists and cybersecurity experts, ensuring the robot's decision-making remains transparent, unbiased, and firmly in your control. Even with all these safeguards, it's natural to feel cautious. That's why Tesla is planning flexible purchase options tailored for folks like you. You'll have the choice of a $5,000 down payment, followed by $500 monthly installments, complete with comprehensive warranty and insurance coverage. For those who'd rather kick the tires before buying, there's a risk-free 30-day trial with 24/7 technical support and a full refund guarantee if Optimus doesn't meet your expectations. And for the most safety-focused users, there's a Medicare Safe mode that limits the robot's top speed and disables non-essential features unless you confirm them with a second command. All of this comes together to make Optimus a genuine partner, not just a gadget. Imagine the relief of knowing that when you need help, you won't have to wait hours for a caregiver to arrive. Picture yourself moving through your home with confidence, reassured by a gentle but capable helper at your side. Think about the peace of mind you'd gain from having your medication schedule managed flawlessly, and the delight of tackling those household chores without lifting a finger. Yes, Optimus still has to prove itself in real-world homes, and it may take a few more months before the first customer units roll out. But based on what Tesla has achieved so far, quietly building production-ready robots that combine strength, finesse, and intelligence at unprecedented scale, it's hard to dismiss this as vaporware. If you've ever dreamed of a personal assistant who's always there when you need it, and never asks for more than a little electricity and a software update, then Optimus might just be the friend you've been waiting for. And when those first machines start working in homes across the country, you could be among the first to welcome a new era of independence, safety, and peace of mind. So are you willing to hand over your most private moments to a machine that's only just learned to dance? And how comfortable would you feel relying on Gen 3's promise of safety when you've seen prototypes stumble and fall? Please share your opinion in the comments section below the video.
So you have to say, what's the ratio of humanoid robots to humans? My guess is it's at least 3 to 1, 4 to 1, maybe 5 to 1. So we're talking about 20, 30 billion humanoid robots. You can imagine like your own personal robot buddy is a great friend, but also takes care of your house. We'll clean your house, we'll mow the lawn, we'll walk the dog, we'll teach your kids, we'll babysit, and we'll also enable the production of goods and services.
Are you really ready to spend tens of thousands of dollars on a dancing robot? Over the past few days, the internet has been buzzing about the latest update video of Tesla Optimus showing off its wireless dancing moves. Sure, it's fun and attention-grabbing, but what the market, and users like us, truly care about is practical, real-world functionality, not just another form of entertainment. So the real question is, will Tesla Optimus actually be able to carry out complex tasks on its own? Tasks like cooking, cleaning, taking care of children like a stay-at-home parent, or working on an assembly line, maintaining factory operations, and handling emergencies without human help? And perhaps most importantly, when will Tesla officially open pre-orders for Optimus? Should we expect that in the fourth quarter 2025? Or is this going to be delayed indefinitely? So what's the truth behind the Tesla Bot Gen 3 presale? While the video of Optimus performing ballet and modern dance grabbed plenty of attention, not everyone was impressed. Many viewers expressed disappointment, arguing that a dancing robot is hardly groundbreaking, neither for Tesla nor for the robotics industry as a whole, where such demos have become all too familiar. If you've been paying attention, Unitree released a similar video of a humanoid robot dancing just a few months ago. Since then, the company has followed up with even more eye-catching videos featuring robots performing martial arts, dancing, and even doing backflips. There's clearly a wave of companies advancing in the humanoid robotics space, and real progress is being made. But among all of this, we're particularly impressed by Tesla's latest robotic hands for Optimus. They stand out above everything else we've seen. This serves as proof of what the latest robotics technology can support in terms of movement. And all of Tesla's demonstrations showing Optimus performing genuinely useful tasks are exactly what we've been hoping for: a humanoid robot that can truly integrate and coexist with our daily lives. Critics are calling on Tesla to release real-world demonstration videos of Optimus performing practical tasks like cooking, washing dishes, folding clothes, or assisting the elderly. These are the kinds of jobs consumers truly care about and are willing to pay for. After all, a humanoid robot shouldn't just be a flashy showpiece. It needs to become a reliable helper in everyday life and work environments.
It'll basically do anything you want. So it can be a teacher, babysit your kids, it can walk your dog, mow your lawn, get the groceries, just be your friend, serve drinks, whatever you can think of.
If Tesla wants to build trust and drive genuine demand, they need to focus on proving Optimus's effectiveness in real-life situations. Those moments where buyers like us are willing to pay for convenience and practical value. Tesla has already teased some glimpses of this. Optimus receiving deliveries, watering plants, serving drinks, tidying the kitchen, and fetching items from a car trunk. These are exactly the kinds of demonstrations customers want to see more of. To back this up, CEO Elon Musk told shareholders that Optimus represents a multi-trillion-dollar opportunity for the company. Musk believes Tesla will eventually produce tens of millions of Optimus robots annually. Tesla has already deployed some robots inside its factories, and Musk hinted that Tesla could begin selling robots to external customers as early as next year. He priced each robot between $25,000 and $30,000. A few months ago, we shared an update on Tesla Optimus's latest mobility capabilities, showing significant improvements compared to competitors like Figure, X1, Unitree, Xpeng, and many others, companies that have been around for decades. So, why is Tesla Bot Gen 3 leading the robotics industry?
It's got the real-world AI. So Tesla's the leader in real-world AI. What we learned in the car, we translate to the Optimus robot. And we also take our expertise in electric motors, in batteries, power electronics, structural design. And then another major important thing is that we're very good at manufacturing.
While competitors show off flashy features, Optimus captures our attention in a completely different way. It redefines reality. Imagine a robot that communicates as naturally as Hanson Robotics' Sophia, moves with the agility of Boston Dynamics' Atlas, and supports human life in ways Toyota's THR-3 can only dream of. Now, imagine it doing all of that with 99% autonomy. Yes, 99%. In a world full of bold promises, Optimus stands out as the only humanoid robot truly capable of independent operation, cutting human dependency down to just 1%. Have you ever tried holding a screwdriver or power drill without bending your fingers properly? Those extra joints make all the difference when gripping small tools. This feature isn't just a nice-to-have, it's an absolute must for performing multiple tasks at once. To really understand why, we've got proof for you right here. Tesla claims that Optimus will revolutionize the labor economy by offering a cost-effective alternative to human workers. According to a February 2025 report, the total cost of ownership for one Optimus over 5 years is estimated at around $105,000, nearly half the cost of hiring a new entry-level worker in Los Angeles over the same period, approximately $223,900, including wages and benefits. That translates to potential savings of over $100,000 per robot in 5 years for companies, especially in manufacturing and logistics. Analysts at Deutsche Bank estimate that Tesla's current production cost per robot ranges from $27,000 to $76,000, with expectations that economies of scale and improved manufacturing efficiency will drive that cost even lower, targeting a price under $20,000 per unit by 2025 or shortly thereafter. Elon Musk has even hinted that the production cost could eventually drop to as low as $10,000, which would significantly boost the robot's cost competitiveness.
You also need to be very good at scale manufacturing. So in order to have the robot not cost like hundreds of thousands of dollars, in order to make it cost like $10,000 or $20,000.
On top of that, Tesla plans to offer Optimus through both purchase and leasing options, with annual lease pricing expected to fall between $3,000 and $3,500. This allows businesses and individuals to test the robot's utility before committing to full ownership. Such a flexible pricing strategy enhances affordability and lowers the barrier to entry. Therefore, while the initial purchase price may be higher than some expect, Tesla's cost-saving strategies, leasing options, and projected production scale strongly support the claim that Optimus will be an affordable and cost-efficient labor solution throughout its operational lifespan. One of Optimus's standout features is its 22 degrees of freedom d'oeuf in the hands alone, an unprecedented level of dexterity for a commercial humanoid robot. Most existing robots have hands with only 5 to 6 degrees of freedom, limiting them to basic grasp and release actions. In contrast, Optimus's hands can move, rotate, bend, twist, and tap objects independently with remarkable precision. The engineering behind this design is inspired by human anatomy. Tesla relocated the actuators from the hand into the forearm, using elastic cables that mimic human tendons to control finger movements. This design reduces the hand's size and weight, enhancing agility and improving energy efficiency. Integrated force feedback sensors allow Optimus to sense grip pressure and adjust in real time, enabling it to hold fragile objects, like eggs, without breaking them, tighten screws with the correct torque, and even distinguish objects by their softness or firmness. This level of dexterity enables Optimus to perform complex tasks such as typing on a keyboard, playing the piano, washing dishes, and safely handling tools, significantly expanding its potential applications in industrial, commercial, and even household environments. From an occupational health and safety perspective, this means Optimus can safely take over hazardous or repetitive tasks, reducing workplace injuries and improving overall efficiency. However, the sophistication of these hands also introduces technical challenges. The weight concentrated in the forearm affects balance and continuous operation. And the protective covering for the hands must strike a balance between durability and tactile sensitivity. Tesla's ongoing refinements aim to optimize these elements to maintain precision and reliability. Overall, the 22 degree of freedom hands are not just an engineering breakthrough. They're a practical enabler that makes Optimus more versatile and effective, pushing it closer to becoming a truly multifunctional humanoid robot. In terms of continuous operation, Tesla has engineered Optimus to balance power consumption with real-world work demands. While exact battery life specifications haven't been publicly disclosed in detail, insider industry insights and Tesla's own statements allow for reasonable inferences. Tesla's use of automotive-grade lithium-ion battery technology, shared with its electric vehicles, suggests that Optimus can operate continuously for around 10 hours before needing a recharge. Early projections and Tesla's factory deployments indicate that Optimus is capable of working in shifts similar to human labor, with battery swaps or scheduled charging breaks integrated into the workflow. Thanks to Tesla's expertise in fast-charging technology, downtime for recharging is expected to be minimal, roughly 10 minutes to replenish up to 70% of the battery. Maintenance protocols are designed to be as streamlined as possible. Tesla's modular design allows for relatively easy replacement of wear and tear components such as actuators and sensors. The company's pilot production and validation runs focus heavily on achieving a yield rate above 95%, implying high reliability and reduced repair frequency. Furthermore, Tesla's software-driven diagnostics are expected to enable predictive maintenance, alerting users before failures occur. Elon Musk emphasized that the robot shares many parts and manufacturing processes with Tesla's electric vehicles, which typically have a lifespan of 8 to 10 years or more under regular use, with some components requiring replacement after a few years depending on usage intensity. Tesla's warranty and service packages, including software updates, will support Optimus's long-term performance and reliability. In practical terms, Optimus is designed to operate in factory or commercial environments with work cycles comparable to human workers, including breaks for charging and maintenance, rather than running continuously 24/7 without interruption. This approach balances battery limitations with operational demands and safety considerations. When will Tesla officially open pre-orders for Tesla Bot Gen 3, and who will be the first owner? According to the latest updates, Tesla's humanoid robot, Optimus Gen 3, appears poised for a limited commercial release in the US as early as the fourth quarter 2025, perhaps even by late October, depending on the flawless execution of pilot production, safety certification, and supply chain coordination. Recent technical demonstrations, an accelerated production timeline, and fast-tracked regulatory processes all provide compelling evidence that Tesla may actually hit this ambitious target. Even for the most skeptical observers, a demographic that values reliability, proven engineering, and transparent milestones, this analysis pulls together key advances in hardware, production scalability, and regulatory readiness to argue that Optimus may go from factory floor to commercial rollout much faster than critics had anticipated. First, technical readiness. Hardware maturity meets AI breakthroughs. It's fair to say that Tesla Optimus has now achieved unprecedented levels of mobility and autonomy. The wireless dancing video, released on May 14, 2025, marked a turning point. Unlike earlier versions limited to scripted tasks, this untethered robot demonstrated 22 degrees of freedom in its hands, double that of previous models, and dynamic balancing algorithms capable of real-time pivoting and weight redistribution. These advancements stem from Tesla's sim-to-real AI training pipeline, where reinforcement learning in virtual environments enables the physical robot to adapt to unpredictable real-world scenarios. For older, more skeptical audiences who often dismiss AI as overhyped, this visible progress, validated by third-party robotics experts through detailed video analysis, serves as strong evidence that Optimus can operate autonomously in complex environments without human intervention. In addition, durability has been most convincingly validated inside Tesla's own factory. Since April 20, 2025, Tesla's pilot production line in Fremont has assembled 200 units of Optimus for internal validation. The reported production yield has exceeded 95%, thanks to shared components with Tesla vehicles, such as battery packs and sensors, which help reduce supply chain bottlenecks. During Tesla's first quarter 2025 earnings call, Elon Musk emphasized that Optimus's drivetrain leverages the existing Model Y manufacturing infrastructure, enabling a rapid scale-up to thousands of units by the end of 2025. For retirees familiar with industrial automation, this kind of cross-platform synergy reflects the kind of reliability that defined American automotive giants like Ford during the 20th century. We can't underestimate it. Scalable manufacturing is Tesla's core competitive edge across EVs, space, and now AI and robotics. A key example is Tesla's projected timeline. Just 6 weeks from the May 15th demo video to ramping up from R&D to production, in line with Fremont's current ability to retool lines rapidly. The Cybertruck ramp-up in 2023 already showcased Tesla's ability to compress validation phases by running parallel stress tests on subsystems, example, motor controllers, vision systems. With Optimus' modular design, Tesla can isolate faults in specific joints or AI modules, significantly reducing debugging time. So, who exactly will be the first to own these high-end bots? Based on Tesla's current product naming and rollout process, the initial Optimus units will serve small-scale production and logistics roles in sectors traditionally dominated by men over 50. Tesla emphasizes the robot's ability to consistently perform repetitive tasks, such as pallet stacking and quality inspections, without fatigue, thereby reducing workplace injuries, a prime concern among older workers. Early adopters, including manufacturing companies and mass production industries, are expected to trial the Optimus prototypes and deploy them for tasks like inventory management, with efficiency gains predicted to exceed 30%. To ease concerns over the upfront cost, estimated at $25,000 to $30,000 per unit, Tesla is developing a leasing program with bundled maintenance included in monthly payments. This model, which has proven successful in Tesla's solar division, is especially appealing to retirees on fixed incomes. Additionally, a 5-year warranty that includes AI software updates reflects a commitment to long-term customer loyalty, a cultural value especially important to older Americans. With a price tag of $25,000 to $30,000 and a leasing option around $3,000 to $3,500 per year, would you be willing to buy or lease a robot like Optimus? Do you think this price is reasonable, given the convenience and functionality it offers? Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss our latest videos. Never before has a project stirred the world's imagination quite like Tesla's Optimus Bot, but the thunderous applause often muffles the lingering concerns few remember to mention. In nearly every video Tesla has released, viewers wonder whether they're seeing meticulously staged footage, slick CGI rather than the real thing. Beyond the spotlight-lit dance sequences, ordinary clips of the robot hauling groceries, folding laundry, or navigating a chaotic family room are conspicuously absent. Consequently, most fans oscillate between amazement and anxiety. They trust Elon Musk's bold vision, yet crave concrete proof that Optimus can transcend novelty and justify its expected 5-figure price tag. So, will Optimus truly astound us with real-world utility, or merely deliver another cleverly choreographed performance? And are 2000 Tesla Bot Gen 3 actually on track to debut even sooner? Welcome to the Tesla car world. How does Tesla Bot Optimus stack up against Figure 02, Atlas Next, and Digit 54? When enthusiasts argue about humanoids today, they usually trade viral clips. Optimus folding laundry, Figure 02 stalking a BMW line, Atlas Next vaulting over a crate, Digit shouldering a tote. Those moments are fun, but numbers decide whether a robot leaves the lab. So Lu Nhu the now. Tesla's Optimus Gen 3 tips the scales at approximately 57 kilograms, meaning 125 pounds, and stands 1.73 meters tall, essentially human-size Figure 02 shadows that silhouette 70 kilograms, 1.68 meters, 20 payload. Because its brief is identical, fit anywhere a person can. Atlas Next is slightly burlier at approximately 80 kilograms according to Boston Dynamics' own electric model press notes, a trade-off for gymnastic headroom. The lanky Digit 54 splits the difference, 76 kilograms with a 16 kilogram carry limit. Weight on a spec sheet is really a proxy for energy. Every extra kilogram punishes runtime. Tesla equips Optimus with a high-quality automotive-grade 4680 battery pack, which has a capacity of 2.3 kilowatt-hours. This is enough to power the robot through an entire 10-hour work shift, based on an average energy usage of 500 watts per hour. In terms of electricity cost, running Optimus for 10 hours would only use about 5 kilowatt-hours in total, equivalent to approximately 44 cents in electricity at standard industrial power rates in the U.S. Midwest. By comparison, the Figure 02 and Digit robots are reported to last only about 5 hours per battery charge. They consume similar amounts of power per hour, but use smaller battery packs, which limits their runtime. Both sip similar watt-hours, but simply carry fewer cells. Atlas is quiet on numbers. Boston Dynamics still treats runtime as an R&D variable, but engineers tracking the reveal estimate a 4 kilowatt-hour slab. Bottom line, Optimus already matches human shift length on the cheapest juice bill in the pack. Walk the Fremont line and you'll see Tesla's one-piece drive unit actuators the size of a soda can driving hips, knees, even finger knuckles. Each includes a motor, gearbox, sensors, and an ASIC on a single casting. Bank of America's supply chain note pegs the current bill of materials for the whole robot at US $50,000 to $60,000 and falling fast as those drives leave prototype machining for gigapresses. Musk's public tweet still targets a sub-US $30,000 sticker when volume hits tens of thousands of units. Figure also rolls its own drives, but at lower torque. Its knee tops out around 170 Newton-meters compared with Tesla's claimed 250 Newton-meters. Hip figure, revealed in recruiting slides last quarter. No cost disclosures, yet in-car magazine coverage of its BMW Pilot quotes an internal hardware line of $70,000 per unit. Digit mixes off-the-shelf servo pods with custom ankles, keeping BOM lean enough to offer a robot-as-a-service price of US $10 to $12 per hour today, and a stated goal of US $3 per hour. When RoboFab in Oregon reaches 10,000 units a year, Atlas still uses bespoke everything. Analysts casually put it in upper six figures, an order of magnitude above the others. Right now, Optimus comes in at around $20 per Newton meter, and that number could drop to just $12 as production scales up and hits Elon Musk's $30,000 price target. In comparison, Figure sits at about $35 per Newton meter, and Digit is even higher, over $50. As for Atlas, we can't really measure it. Boston Dynamics is great at showing off flashy moves, but they haven't shared much about actual unit costs. A humanoid is only as scalable as its parts list. Tesla's obvious ace is vertical integration. The FSD computer that crunches video in a Model Y now rides in Optimus's chest, and the 4680 cells roll off the same gigafactory drums as Cybertruck batteries. That gives Fremont a credible path to Musk's first legion of 5,000 robots in 2025, with parts for up to 12,000 on deck negotiating carve-outs, but says it can still reach thousands this year. Figure leans on German automaker BMW for its first industrial deployment. The Munich body shop pilot reported a 400% pick-and-place speed jump once Figure 02 took over a gasket line. Scaling beyond the pilot means converting a Bay Area cleanroom into a 12,000 units per year plant. Funding is in place, but the supply chain is almost entirely contract manufactured. Digit's RoboFab is smaller. It is already stamping chassis and shipping Ray-S contracts to Spanx and Amazon facilities. Atlas, backed by Hyundai, now has an automotive lifeline, but Boston Dynamics has never mass-produced a humanoid, only spot and stretch. Software matters as much as assembly. Tesla and Figure both rely on end-to-end imitation learning pipelines, feed video, fine-tune on NVIDIA clusters, deploy zero-shot to the robot. Digit runs a more deterministic skill library. Atlas sits at the bleeding edge of reinforcement learning, able to backflip but not yet fold shirts. For a customer deciding which bot can be trained on new tasks every Monday, Tesla and Figure have the clearer story. The net is a chessboard, not a coronation. Tesla's cost per torque advantage is meaningless if magnet export controls choke actuator output, or if safety certification slips. Figure must prove its hand dexterity is worth $40,000 extra. Digit must extend runtime and reach. Atlas must prove it can even be bought. But for now, if you're a plant manager doing the math on lifetime payroll versus capital expense, only one bot drops below 1 human year of wages. Optimus at 0.0. That single data point explains Morgan Stanley's $5 trillion total addressable market headline for humanoids by mid-century. Expect the next volley in the teardown war to land on hands and brains. Tesla's actuator team is already testing three-piece fingers to close the dexterity gap. Figure is racing to slash battery mass. Digit is integrating NVIDIA's Isaac Sim to learn entire warehouse workflows in the cloud. Boston Dynamics is courting Hyundai parts data to teach Atlas to torque bolts, not just throw tool bags. For viewers hyped by dance videos, numbers like sound dry. Yet those ratios decide which prototype becomes an appliance. In 2025, the leaderboard, Optimus on cost and energy, Figure on touch, Digit on price per hour, Atlas on stunt power, shows four radically different design philosophies chasing one unmet promise: a robot cheap enough, capable enough, and safe enough to clock in beside us. When that happens, you won't learn it from a viral backflip. You'll notice it because your warehouse headcount spreadsheet suddenly balances itself. Strip away hype, and each contender is a bundle of trade-offs. Tesla's vertical integration buys cost density, no rival yet matches. Figure bets that human-like hands will justify premium pricing. Digit proves subscription can beat sticker shock. Atlas sells raw athleticism. The teardown war is far from over, but today cost per Newton meter tells the blunt truth of who's closest to a robot you can actually afford, not just watch. What happens when 2,000 Tesla Bot Gen 3 units clock in 2025? Picture this. It's 7 a.m. on a Monday in 2027, and a fresh shift of 1 million Optimus units rolls onto U.S. factory floors. Each bot plugs itself into the ERP system, checks the schedule, and starts welding, packing, or palletizing before most human workers have poured their first coffee. That image isn't sci-fi bravado. It's a back-of-the-envelope forecast rooted in today's hard numbers, and it tells a surprisingly upbeat story for manufacturers, investors, and even workers. Manufacturing wages hit $35.06 per hour on April 20th, 25, their highest real level on record. Yet factories still can't hire fast enough. The U.S., the chamber counts 620,000 unfilled manufacturing jobs, and census capacity data show 20.6% of plants that failed to run at full tilt blame a lack of labor or skills. That shortfall drags on GDP, slows reshoring efforts, and forces companies to pay ever-richer overtime premiums. Enter a robot that never calls in sick. Elon Musk now pegs an eventual Optimus sticker price at under $30,000. At today's wage line, a single human operator costs roughly $70,000 per year. Swap that worker for a $30,000 robot that can match the output, and the capital recoups itself in 5 months. Just 0.43 years by straight division. After that, every shift the bot works is pure margin upside. That math is why Morgan Stanley analysts call humanoids a $5 trillion annual market by 2050. But robots need power. True, yet the numbers are laughably small. Tesla's published specs list a 2.3 kilowatt-hour 4680 battery while walking. 10 hours of brisk walk burns 5 kilowatt-hours. Compare that with $350 in wages for an equivalent human shift. Energy is a rounding error. Now scale up. 1 million Optimus units would supply roughly 2 billion labor hours a year, enough to erase the current manufacturing job gap 3 times over and restore production at the 20% of plants now throttled by missing staff. If each recovered percentage point of capacity adds 0.02% to GDP, historical BEA elasticity, the Robot Legion nudges national output by 0.4%, or $110 billion on a $27 trillion economy. And that's before counting spill-over gains from shortening lead times and reshoring new product lines. Crucially, the index doesn't assume humans vanish. Instead, high-skill technicians step up the value chain, programming, maintaining, and co-piloting fleets of bots, roles that already pay a premium. Think of Optimus less as a job killer and more as a living exoskeleton for the U.S. industrial base. It lifts the floor of productivity so that human ingenuity can raise the ceiling. If you're an investor, 5-month payback and trillion-dollar scream optionality. If you're a tech skeptic, the 44-cent energy bill versus $350 wages reframes the hype. And if you're one of the 622,000 vacancies still posted on Indeed, an Optimus partner could cut your mandatory overtime or free you to take a higher-skilled post. That's the promise behind our GDP Booster Index. Robots don't just dance, they pencil out. How crazy are the new capabilities of the Tesla Bot Gen 3 really? Honestly, Optimus could outshine anything we've ever seen by a long shot. Now picture this. Your very own robotic companion, one that lives in your home, helps look after your kids, and can even step in as a personal tutor or in-home teacher. When most people hear the term humanoid robot, they tend to imagine a shiny sci-fi future where machines take care of the dirty, dangerous, or downright boring tasks we'd rather avoid. Who hasn't daydreamed about a robot that cooks, cleans, and handles all the annoying chores? But alongside the excitement comes a wave of anxiety. Some worry about robots replacing human jobs, or worse, dominating humanity in some dystopian scenario straight out of a movie. And then there are those who still see humanoid robots as a bit of a joke. Slow, clunky, stiff-legged machines that seem more like expensive tech demos than anything practical. To be fair, they weren't entirely wrong, until recently. Over the last 2 years, the game has changed dramatically. We're not talking about minor improvements, we're talking about serious leaps forward. What used to be a narrow competition between Tesla and Boston Dynamics has evolved into a global showdown, with major players from the US, China, and beyond diving into the race. Now, we're not saying Tesla's robot is the smartest one out there, but what makes Optimus stand out is its real-world potential and its path to mass production. This isn't just another prototype meant for flashy demos. It's being built to be part of people's everyday lives. And for the first time, owning a humanoid robot doesn't sound like a far-fetched fantasy. With a target price range of around $20,000 to $30,000, Optimus could actually be within reach for regular folks. The key? Scalable manufacturing. That's how Tesla plans to keep the price down and deliver a robot that doesn't cost a small fortune. Most humanoid robots today don't survive beyond the headlines. They're shown off once or twice, blow us away with fancy tricks, and then disappear. That's the reality. But Tesla has flipped the script. They recently unveiled 50 Optimus units at a major event, giving attendees a chance to see them up close, not just on stage or in videos. Ironically, the event was supposed to highlight Tesla's Cybercab, their autonomous robotaxi. But it was Optimus that stole the show. People didn't crowd around the car, they surrounded the robots. That moment was a turning point, proving that Optimus is more than just marketing buzz. It's already doing things people actually want help with: sorting packages, making drinks, folding laundry, charging EVs, watering plants, carrying heavy items, playing games, dancing, and even answering late-night questions. All of that has been achieved in under 2 years. Even Boston Dynamics, one of Tesla's fiercest competitors, gave them credit for the progress. Now imagine a robot that can work 8 to 10 hours straight without needing a charge, and when it does need power, it recharges itself. Sounds like science fiction, but that's what Tesla has built. Thanks to the cutting-edge 4680 battery, Optimus doesn't need manual charging. It finds the charger, plugs itself in, and gets back to work once it's topped off. Early versions of Optimus used 2170 battery cells, which were bulkier and less efficient. But the introduction of the 4680 cells has changed everything. These newer batteries are 5 times more energy-dense and cheaper to manufacture, leading to a sleeker, lighter design. The second-gen Optimus is 22 pounds lighter, now weighing 138 pounds compared to the original 160. And it's not just about shedding weight. The higher energy capacity, up to 3 kilowatt-hour, means Optimus can run for an entire workday without stopping. Unlike electric vehicles that take 30 to 40 minutes to charge, Optimus could potentially recharge in as little as 10 minutes if done wirelessly. This level of autonomy is unmatched. No other robot on the market can work this independently and recharge itself. Tesla is setting the standard. Between Tesla's Optimus, Figure 02, Digit, and Atlas, who do you think is leading the humanoid robot race and why? Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla, EV, or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss our latest videos. We appreciate your support and look forward to seeing you in the next video. Goodbye.